Okay, so we talked a little bit about it yesterday. We're going to look at the discriminant. And today is the 5th. I believe it's March already.
I feel like that's crazy. This one is so fast. That was crazy. It's probably gonna be dead soon. Really?
Alright, so we did, just going back to our, so remember, the discriminant. You know what, let's start again. See, we're all tired. For a quadratic equation, ax squared plus bx plus c the discriminant is defined as and you may see this sometimes, they may call the discriminant a little triangle like that. And they say it's b squared minus 4ac. Okay? So the little triangle just means discriminant. And you should all recognize the discriminant b squared minus 4ac because that is the part underneath the square root sign in your quadratic formula. Yeah? So we did. Yep, Karen?
Isn't the triangle like changing?
Yeah, it's also used as like change in something. So if I was to write, change in y, that means change in y, okay? But I think that's just a coincidence.
Does it still work if you don't have like C or don't have B?
Yep. Mm-hmm. So we did a few examples of these. The first one was, what was the first equation we did last time? 2x squared
Minus 5x
minus 5x minus 3. Okay, so our values, A is equal to 2, B is equal to negative 5, C was equal to negative 3. And this gave us a discriminant of, so b squared minus 4ac is 49. That's 12, 24. Right, and that number is positive, okay? It is greater than 0. I'm going to do more stuff on this side as well in a second, okay? So you might want to leave a bit of room on the right-hand side. If I give us the equation, work out the discriminant for me on this one. It's x squared minus 2x plus 1. Work out what the discriminant is here, please. Yeah, so 25, take away 4 times negative 3 times 2. Yeah? Good? Okay, so work out the discriminant for this example. Say again?
No, because it's plus.
A is
Negative 1. The one below.
below here.
Yeah.
Oh, yeah, my bad. Thank you, Marco. A is 1. A is 1, B is negative 2, C is 1.
Ooh.
What do you get?
0.
Right. That is equal to 0. Now what I want you to do is find for me, for this example, the roots. What do I mean by roots? Good. Find the roots of this equation. Well, just write down you're working whichever way you're doing it. Okay, so you could factorize this. If I'm going to factorize, I want two numbers that multiply to give,
1.
but add to give,
2. 2 is 1.
add to give,
Negative 2.
so it's going to be,
1. Negative 1.
right, 1 and negative 1? Yeah, it's going to be negative 1
Oh, yeah, sorry.
and negative 1. It's negative 1 times negative 1, positive 1. So that tells us that x is equal to 1. Okay, one value only, yes? Actually, it is two values. It's x equals 1 and x equals 1. Okay, so we said that this is a...
Wait, are you sure it's 1 negative 1? There's a quadratic formula for me.
So we'll do it with the quadratic formula as well. So it's minus b, so it's minus 2, plus and minus the square root of b squared minus 4ac, which is actually just 0, all over 2a.
Oh, yeah, okay. It was 1 because I thought it was negative 2.
Yeah, so it's negative 2, so it's 2 over 2, which is 1, okay?
Why is there only 1?
One root. Okay, because
It's not a function.
it is not a function, but none of these are functions, remember?
It's a... Aren't
Well,
they?
no, sorry. They are functions. They're all functions. And this is a function. Yeah, this is still a function.
Yeah,
Okay.
it just... the vertex is not...
Right? Yeah, sorry. They are all functions. They all don't have inverses. Okay? But they are all functions. Let me rephrase that. They are all functions. They have inverses, but the inverses are not functions.
Gotcha.
Okay? So we've got a repeated root. Okay, now if I was to draw this, actually tell me what is the the y-intercept out of interest? Yep, the y-intercept is when x is equal to 0, when x is equal to 0, y is equal to, when x is 0, y is equal to 1. So if I was going to draw this, it's going to look something like my steady hand, so it's going to go through 0, 1. It's also going to go through 1, 0. Yes? So my curve is going to go
Wait, how is that inverse wrong?
Okay, so the graph touches once, okay? And remember, this is going to be a nice smooth curve. It's touching the x-axis at one place, okay? All right. What's the vertex of this one?
1 or a 0. No, 1 0.
1 0. Okay, so the vertex is right at this point as well. Okay. Now, when we did this one, example 1, what did we notice about what were the roots? What did we work out the roots to be? You can just look back for the first example here.
-1/2 and 3.
So we worked out the roots before, so we did that in the last couple of lessons. Say that again. X is equal to.
-1/2 and 3.
Oops, x is -1/2. And x is equal to 3. And you could do that factorizing, you could do that using the quadratic formula.
It's -1/2.
Oh, sorry, -1/2 and 3. And so we've got how many roots here? Right, so we have got 2 real roots, okay? This one, we have got 1 repeated root, okay? I'm just going to put in here that it is 1 repeated root. All right, our last kind of example is to do with the one that we were looking at yesterday. So the final one, back to blue. You okay? So I had 2x squared minus 3x minus 11. That was the one that we looked at yesterday. So A is 2, B is -3, C is -11. So our discriminant, in this case, B squared, so -3 squared. So I get 9. Sorry, it was plus 11, wasn't it?
It was -5.
Okay, well, I'll just leave it as 3 for now. That's plus 11 and the example that we want. So I get 9, take away 88. 9 take away 88. Right, which is a negative number. Now, when we also realize when we come to do ones like this, because this is negative, what does that tell us? Right, yeah, if we use a quadratic formula, we're going to end up with the square root of a negative number. And we know that we can't take the square root of a negative. So this one has no real roots.
Is there any way to find the imaginary roots?
Yes.
If as imaginary.
So it's got no real roots, okay? If I was to draw it,
What better word for imaginary?
complex. So I'll talk about that in just a second. So this one, I know that it's going to go through 0, 11. And it's going to come down. So your graph is going to come down like this. But it does not cross the x-axis, yes, because it has no real roots.
Yes.
All right. No, it's got no real roots. So remember, real numbers are just any kind of number that we're used to dealing with. Okay.
What would the root be then?
Well, it's got no real roots.
No, but because you said we could find complex or imaginary.
Okay. Now this
What would
is
they be?
going into diploma maths. Okay. We will just
No.
briefly talk about it, right? It's got no real roots, but it does have complex roots. Now you'll do this at higher next year. Okay? Now a complex number is made up of two parts. Okay? It's made up of a real part, and it's also made up of an imaginary part. No. Okay, so complex numbers are made up of real parts and imaginary parts. Now the real part is easy, we all know what a real number is, okay? 5 is a real number, pi is a real number, root 2 is a real number, yep? Imaginary numbers, they come from the fact that the square root of -1 is equal to, okay, if you put this into your calculator, it's going to say error. So what mathematicians decided to do, and this all comes back to your theory of knowledge, which you'll do next year, is was this stuff actually invented or did it always exist? We say that the square root of -1 is equal to I, okay? Which stands for imaginary. And we can treat imaginary numbers, you know, if I've got I plus I, that is equal to 2I, yeah? Just treat them like normal numbers, okay? It just so happens that I is equal to the square root of -1, okay? So answer for me, what is I squared equal to? -1, because it's square root of -1 multiplied by the square root of -1, which is -1. Yeah? What is I cubed equal to?
1.
-1 root -1, which is the same as negative I. Because root -1 is I. Yep. So there's going to be a little pattern to this.
I want to learn that.
Are you with me?
Yes.
What about I to the 4? Okay, how do you work it out? It's going to be
Is it
I to the 4
It's just -1.
is going to be not -1.
Is it 1? Root 1.
How do I work out I to the 4 using the information above? Somebody tell me.
Yeah,
It's not hard.
Because I squared times I squared.
Okay, I could do I squared.
That's gonna be 1. So -1 times -1 is 1. That's what is it 1?
All right.
Did I get it right?
Yep.
Yes.
So what about I to the 5? Just multiply this by. Yeah, and get.
-1 root.
You're complicating it.
1 negative root. What?
What's I to the 4 equal to? 1.
Root negative.
So I to the 5 is just equal to?
I.
Yep, which is the same as I. So we can see that we've got a nice pattern going on here, and it repeats every power of 4. Now this is why it's really important that you understand exponents. Okay? There's nothing really that complicated going on here. It's just a little pattern. Okay, that if you know your exponents, it's dead easy to kind of work out. Okay? So what we're saying is, although this does not have real roots, there will be complex roots that we will be able to find for this equation, okay? And they will involve a real part and an imaginary part. Okay, and this is something that you will do next year. Okay? Well, the thing is, it's difficult to visualize, and I'll probably not be able to draw it very well. So this is your real plane, okay?
Yeah.
So they do not lie in the real plane because they are not real numbers,
So
okay?
they're like dystopian.
They are complex numbers. So they lie. We can create another plane here, okay? So and imagine that this is my, and I need to actually just look this up just to make sure, but you can create another line here which is going to create my real plane, okay? And it's to do with the real plane, but it's not as straightforward as this curve, you know, cutting through the line and creating them, okay?
But can you graph imaginary?
You can graph them, yeah, but it's difficult to do it on a 2D graph, okay?
Desmond, can you do
I don't think it would, no.
Oh god.
But they're quite straightforward to use. Now, the really good thing about these is, I don't want to go off topic here, but I am doing. Complex numbers, so for imaginary, so for example, this is a complex number, 3 plus I, okay? All that means is it's just 3 plus root negative 1, okay? But you would always just write it like this. Now, you can also write these numbers in terms of sine and cos, okay? And this is called
That was on the stats.
trigonometric form.
And what does that mean?
It's just another way to write these numbers.
And would you do that
Complex
in
numbers.
analysis next year?
Yes.
Standard
And then you
analysis?
can also write them, so you can write them in trig form, but you can also write them in exponential form, where you would have e's involved.
Oh, did you go to the conference?
So there's lots of different ways that you can write these, but the really good thing is it brings lots and lots of different bits of mathematics together. And it'll start to be like, oh, that's where that comes from, or that's why that's important.
You would learn standard. Yes.
You would learn, I think, a little bit of complex numbers in the analysis course, but only a little bit.
Well, like the higher standard
Higher, yes.
analysis.
A little bit, I think, yes.
We went to the course.
Practical application.
Yeah, no, there's lots of practical. It's to do with electrical engineering.
Yeah, that's
No, I don't know the ins and outs of it, but it is used. It's used as a lot of practical applications for it.
How do you practically
All right, let's copy this down. The discriminant tells us what? What does it tell us?
the roots?
Well, it doesn't tell us what the roots are.
It tells us how many.
It tells us how many roots a quadratic equation has. And this is important. It does not tell us what the roots are. It just tells us how many. So for example, if we have b squared minus 4ac, if we work out the discriminant and we find out that it is greater than 0, this tells us what?
It's a positive number. No, it's 2 roots.
It has 2. What do I mean by the word unique?
They're not the same.
Yep. 2 unique or distinct, different roots. And if that is the case, our graph either looks like this. Okay, we've got one root there, one root there, or don't overlook the other case where it could be like
Yay!
here or here. Okay? 2 equal roots. Sorry, 2 distinct roots. Alright. Second case. b squared minus 4ac is equal to 0. 1 repeated root. In this case, touches once. Or in this case, it might go last case. If b squared minus 4ac is less than 0, that means there are no real roots. Alright, I want you to have a go at the following. The quadratic (2x squared plus kx plus 3) has two repeated roots.
Wait, so one root or what?
Yes.
Find,
Isn't it one repeated root?
Yeah.
or two repeated roots, one repeated root. Find the value of k which satisfies this. Okay, so you have to find the value of k, or the value of, find the values, I'll put in here actually, of k which satisfy this. So that means there may be more than one answer, okay? And so you have to find the values of k to make this have only one repeated root. Alright, so the first thing that you must do, Samara, is write down, okay, if you've got one repeated root, you know that the discriminant, b squared minus 4ac, is what? It's got one repeated root. What's the discriminant? It's equal to 0, okay? Now you do that, at DP, you are guaranteed yourself a mark, okay? So you must write that down, okay? If it's got two unique roots, then you put it greater than 0, okay? You put the inequality to whatever the question says, but you get marks for this. What is B? Right, so I've got k squared minus 4 times a times c. So k squared minus 4 2s are 8, 3 are 24. K squared equals 24. Lily? Take the square root. What's this? Okay, that's plus or minus. Good. Plus or minus the square root of 24. So I've got two answers. Let's just simplify just as a bit of review. How can I simplify root 24? It's the same as root 4 times root 6, which is 2 root 6. It's also the same as 8 root 3. 2 root 2, yeah, it's the same thing. Okay, so we get k is equal to positive and minus 2 root 6. So if I was to sub this in, okay, if I was to draw 2x squared plus or minus 2 root 6x plus 3, if I was to draw either of those with a plus or with a minus, my graph is going to touch my x-axis once. Okay, that's what it's telling me. All good?
Can you put that in decimal?
Yep. You want me to do it now?
Yep.
Desmos. Equals. Read it out.
2x squared plus 2 root 6x plus
2, hang on, square root 6 x plus 3.
Oh. Oh my gosh.
So it's really thin, but it is still a parabola. Okay, if I draw the other one, I just copy and paste it. So it is touching exactly one place. If I draw the other, change this to a subtract. There we go. There's the other one. It's touching exactly once. Well, you could put these equal to each other and then figure it out, and yeah, that would work. But yeah, you can actually see, because it's going to be when they cross the y-axis. That is when x is equal to... Yeah, when x is 0, both these graphs are going to be equal to 3, and that's where they're going to intersect. Good.